So yeah, just look at me when you're answering questions.
Okay.
And if you could answer.
So I study the interstellar medium and star formation in the interstellar medium. So this is something that is taking place. All galaxies have an interstellar medium. It's made of gas and a little bit of dust, about 1% dust. The most interesting thing about it is, I would say, how dynamic and complex the system is. So in addition to the gas, there's also radiation, there's also shock waves moving around, there's cosmic ray particles, there's magnetic fields, so it's a very, very complex system. One big question for us has been what determines the rate of star formation. So if you have this much gas in a galaxy, how fast does it turn into stars? That depends on the environment and also on the scale. So, you can have a dense cloud of gas that turns into stars quickly and then disperses. You can have a lower density, kind of average region. How fast does that turn into stars? So in addition to kind of these questions of rates, there's also how does that affect the larger scale? So the process of star formation, stars return a lot of energy to their environment. When stars form, they send energy back into their environment, and that regulates then the rate of new collapse. So really the current generation of stars regulates the future generations of stars. Now we're just starting to work on is how galactic winds are created. So people have thought for a long time that this is somehow related to the effects of star formation. Energy goes into the gas and somehow that drives some of the gas out. And one of the things that we're working on now is to quantitatively measure how winds are driven, what is the phase of winds, is the gas hot versus warm, how does it depend on what kind of galaxy is, small galaxies versus large galaxies. It's measured by looking, basically you can observe the material that's flowing out of a galaxy by looking at the emission in different lines. So line emission, it's basically radiation, in particular quantum mechanical lines. So that's how you measure it. It's actually relatively difficult to measure. So that's one of the kind of issues in the field, is even just measuring what the winds are to know how pervasive they are or are not. Kind of goes back to my graduate days. So I think, I think you sort of start working with someone who seems like they're doing exciting things, and then the more you learn about it, you may stay in that field. I moved a little bit from what I originally started working on. I think the questions, there's a wide range of questions, and also the kind of mathematical techniques I like a lot, and I can sort of think about the physics, kind of the fundamental physics, which is very appealing to me. I like Saturn just because, the rings are so beautiful, and it has a lot that you can see, both the dynamics of the rings, and it also has interesting fluid flow on the surface. So that's another nice thing about Saturn. The thing I like about the Milky Way or nearby galaxies is that there's really a lot of information about them, and so I would say that I like the class of spiral galaxies. I find them much more interesting than elliptical galaxies. Not to say that they're not interesting, but there's just much more going on in spiral galaxies.